Okay, start recording. Today we're going to do chapter 6 numerical methods. Okay, so numerical methods is actually considered a skill, okay, that actually apply in the real world, okay, that actually can be appear in any topics, okay, regardless whether you have a polynomial, quadratic, exponential, log, trigo, or whatsoever, okay, that actually involved with it can be involved with numerical methods. So first of all, you need to understand what exactly is numerical methods. Okay, numerical methods are methods to calculate or calculating approximate solution for equation. So it's a method to solve equation. Okay, so numerical methods actually help us to solve the equation without using algebra methods such as factorization, substitution, elimination. Okay, so we can actually use numerical method is actually like an algorithm way to actually solve the equation. There are many numerical methods in the real world. Okay, in this P3 topic, we're going to deal with iteration procedure. Okay, in the real world, there are many different numerical methods such as interval bisection, interpolation, Newton-Raphson. The one maybe when you're dealing with a different degree in the future, you actually have a chance to actually encounter different type of numerical methods. Okay. So since iteration procedure is the only one that you need to learn for your P3, okay, well, let's go through the iteration procedure. Okay, so what exactly is the procedure? Okay, so okay, step one, identify the equation that we want to solve fx equals to 0. First of all, we need to have an equation. Okay, if I don't have an equation, of course, there's no point that we're actually solving it. Okay, so there must be something that we want to solve, something that equals to 0. Okay, and two, identify the location of the solution by using graph. Okay, that means it may be involved with graph. Okay, involved with any graph that you have done before in P1, in P3. Okay, then or maybe we can actually identify the location by using change of sign. Okay, I will explain further when I using example. I will show you what exactly but that it meant by change of sign. Number three, okay, rearrange fx equals to 0, which is your equation, into the form of x equals to gx. This x equals to gx, we call it iteration formula. Okay, over here, because of due to algebra work, you may get many different gx, but you need to understand that not all works. Okay, for 2019 and before, the question 2019 and before, they're not going to test about the theory, why is it work, why is it doesn't. But for 2020 syllabus, you will need to know that why the GX fail and why is it work. Okay, you need to know about the theory part of it. Okay, step 4, you need to identify the initial value x naught from the step 2, from the information from step 2. Sometimes given by the question, okay, sometimes you need to identify the x naught yourself. Okay, number 5, use the initial value, okay, x naught and the iteration formula x equals to gx and the calculator. Then you're going to start to find the approximation answer alpha. Okay, so the iteration will be x1, x2, x3, and so on. Eventually, if you are approaching to your answer. Step 6, justify your answer by splitting your solution alpha into two values. After that, and you're supposed to show change of sign. Okay, the full iteration procedure you will consider 6 steps. During exam, they may not ask about all the 6 steps. Okay, they may be asking to maybe step 1 ask you to form the equation. Sometimes they didn't give you the equation directly, they give you a situation, they ask you to form the equation. That will be step 1. Sometimes the question asks you to do step 3, ask you to rearrange the algebra to get x as a subject, x equals to gx. Okay, then maybe step 5, okay, they ask you to find the approximation answer. Okay, so therefore, over here, the iteration procedure, you have a full step 1 to step 6, but during exam, they may be just only asking for a certain parts of it. Okay, so please remember this. Okay, you maybe and take a picture of this one first. Okay, for the 6th step before we actually go into the example. Now let us look at example. Okay, I would like to solve x minus cos x equals to 0. Okay, first of all, when we look at this x minus cos x equals to 0, maybe we were asking, can we actually use algebra to actually solve it? We can't, because cos x you cannot write in the any algebra form. Okay, so we have no idea how to actually solve it by using algebra. So this, although that the equation given is x minus cos x equals to 0, but the problem is there a solution? If there is no solution, there's no point that we actually attempt it. Okay, so there must be a solution first before we actually can then try it. Okay, so over here, if we write in the form of x equals to cos x, and we draw a graph of the cos x graph and the y equals x graph, okay, we realize that, hey, there is one intersection in between of 0 and pi over 2. Okay, in between of 0 and pi over 2. Oh, there is a solution. Okay, in between 0 and pi over 2. Of course, at the moment, I have no idea what is the number, but from the graph, I can see that there is a solution. Okay, that means it's actually good for us to actually proceed. Okay, with the working with the calculation. Okay, so now I'm going to implement the iteration procedure. So of course, step 1, I need to have my fx equals to 0, which is x minus cos x equals to 0. Okay, step 2, okay, from the graph, you already can see that there is a solution in between of 0 and pi over 2. Okay, then what if I want to show by using change of sign? Okay, then if let's say I let fx equals to x minus cos x, okay, then I substitute 0, substitute 1, substitute 2 inside the calculation. Okay, remember to set your calculator into radian mode because this is a trigo question. So under this topic, we need to solve the question in the form of radian if it's a trigo question. So x minus cos x. Okay, calculate 0. I will have a negative 1. Okay, calculate 1. I will have a 0.4597. Okay, calculate 2. I have a 2.416. Okay, so over here, by observing the value, I see that this is a negative number, this is a positive number, this is a positive number. There is a change of sign in between 0 and 1. Okay, exists change of sign. Okay, then from here we conclude that, okay, at least one solution in between 0 to 1. Okay, it's just that I have no idea what is the answer yet. I only know it's in between 0 and 1. Okay, I don't care whether it's changing from negative to positive or positive to negative, as long there is a change of sign. That will be step 2. Step 3, okay, step 3 says we need to rearrange the equation. Okay, so from this x minus cos x equals to 0, okay, I can get many different form of writing x as a subject, or maybe I can do x minus max x equals to cos x. Okay, of course this is the obvious one. Then or maybe I can write it as x equals to 1 over secant x. Okay, or maybe I can write it as x equals to arc cos of x. Okay, as you can see, we can actually get many different GX. Okay, many different GX, but which one works? Okay, actually I don't know at the moment. Okay, so just for the sake of working for this to demonstrate to you about the iteration procedure, let's say I'm going to use this x equals to cos x, okay, to continue with the calculation. Okay, step 4, we need to identify our initial value x naught. Okay, initial value x naught. Okay, according to the steps I mentioned here, identify initial value x naught from information from step 2. Okay, so we need to refer to the step 2 information. Okay, step 2 says, okay, step 2 here, we see that there is a change of sign in between 0 and 1. Okay, I have a value -1 and a value of 0.4597. Okay, so observe, between this -1 and 0.4597, which number is nearer to 0? Obviously 0.4597 is nearer to 0. Therefore, I choose my initial value as 1. Okay, so that means we are actually choosing the result that actually nearer to 0. So 4597 nearer to 0. Okay, this is, we do step 4 in the event that the questions is not given to us. Okay, then step 5, I need to do my iteration procedure. Okay, I already have my x naught equals to 1. Okay, I already have my x equals to cos x from step 3. Okay, now I will need my calculator. How do I actually use my calculator to actually form the calculation? Okay, then, okay, for exam presentation, you at least need to show one time of the substitution. So your x1 here will be written as cos of x naught, which is cos of 1. Okay, so you have a value. Then after that, x2, x3, x4, and so on. Okay, you can actually use calculator to actually press the number. Okay, how do we actually use the calculator? So the calculator part. Okay, we see that x naught equals to 1, so I press 1, I press equal. Okay, I press 1, I press equal. Remember to set your calculator into radian mode. Okay, after that, I have my iteration procedure cos x, isn't it? So I press cos, I press answer. Okay, don't forget about the close bracket. Okay, after that, you press equal one time. Okay, so you will see 0.5403 something. So that will be your first approximation, 0.5403023059. So if you press equal again, okay, so you have 0.85755 something. That will be your second approximation, 0.85755322158. Okay, that means all you need to do is just keep pressing equal. So if you press equal for the third time, you have 0.654289790. If you press equal another time, you have 0.7934803587. Okay, when do we stop? Okay, for procedure wise, all you need to do is just keep pressing equal. Okay, and the value stop changing, then you actually can conclude that that will be your answer alpha. So if you keep pressing your calculator equal, okay, eventually you will see your calculator stop changing the value 0.739085132. Okay, you will see that it stopped changing. The value, the answer is a 0.3790 something. Okay, so how many decimal place that you're supposed to present for each of your iterations? Okay, so decimal place or significant figure, okay, depends on questions. Okay, then step 5 already done. Now step 6, we need to justify. Okay, justify the answer. Let's say the questions ask you to justify alpha equals to 0.739 to 3 decimal place. Okay, from here we're going to split the number x equals to 0.7385 and x equals to 0.7395. Okay, then after that we calculate the value 0.7385 for that. Okay, and 0.7395. This time when you substitute the number, okay, you do not substitute into g, you substitute into the f. Okay, so it will be x minus cos x, s minus cos x. So calculate 0.7385. So you have a negative 9.8 times 10 to a negative 4. Okay, calculate 0.97395. 0.7395. Okay, so you have a 6.9 times 10 to a negative 4. So what is your conclusion? There is a change of sign, isn't it? Okay, change of sign. So your conclusion will be, okay, axis change of sign, okay, alpha equals to 0.739 to 3 decimal place. Okay, this is what happened. And this will be the full 6 step for the whole procedure. But whether to as I say, whether should we do all the 6 steps will be depends on questions. Okay. So what about the theory? Convergent and divergent. Okay. We say the sequence is convergent when you manage to get an answer. Okay, can get an answer. Okay, we say the sequence is divergent when you cannot get an answer. In other words, that means x equals to gx fail. Okay, x equals to gx fail. Okay, so theory-wise, okay, how do we actually know whether when is one x equals to gx works or doesn't? Okay, we will look at some diagram here. Okay, so over here, I already prepared a graph, okay, where this one is y equals to x, the red one is y equals to x, okay, the red one y equals to x, and the y equals to x. Then you have the blue one, that is your gx, okay, that is your gx, okay, there is a gx here, there is a gx here. Okay, for easy illustration, I'm going to put all my initial value on the left side of the intersection point, on the left side of the intersection point, on the left side of the intersection point, on the left side of the intersection point. Okay, first of all, I go up to the blue color, then go to the red, go to the blue, go to the red, go to the blue. You will see the direction of the first graph. Will move towards the solution, the intersection point. That means it works. Okay, this one can get the answer. So for the second graph here, I go up to the blue color, then go to the red, go to the blue, go to the red, go to the blue, red, blue, red, blue. You also can see that it move towards the answer. Okay, this one also works. For the third one, I go to the blue first. Okay, go to the red, go to the blue, go to the red, So you'll see that the point is actually going away from the intersection point. That means you can see this one fail. And the last one, if I go to the blue first, then go to the red, go to the blue, go to the red, okay, you see that it's also going away from the diagram, from the intersection point. Okay, this one also fail. Okay, so what is exactly is the condition that actually make it works or doesn't? You can see this one, the first graph is increasing, is going up. This one also increasing. The second graph, this one decreasing. This one, the fourth graph also decreasing. So it's not about the increasing or decreasing that actually matters. It's about the size of the gradient. The size of the gradient. The y equals to x graph give you 45 degree. That means the equation, equation of the tangent here, the gradient over here, is actually lesser than 45 degree. When it's lesser than 45 degree, it works. Okay, this one you can see that when it's steeper, okay, greater than 45 degree, then it doesn't work. Okay, that will be the theory here. For your information, this type of graph we call it a staircase diagram. Okay, staircase diagram, and this the second type of graph. This one we call it a cobweb diagram. Okay, don't be surprised if the word staircase and a cobweb actually appear in the questions. Okay, you just need to understand what is actually the shape they're actually referring. Is the cobweb means it's a spiral one. Okay, spiral type of question. Okay, so next, let's look at how's the exam question supposed to look like. Okay, I have the questions here. The curve with equation y equals to x squared cos half x has the stationary points. They give us stationary point and x equals to p. Okay, remember I told you step 1, anything that can ask us to solve equals to 0 can be appear under this topic. Okay, so stationary point means what? Stationary point means dy dx equals to 0. That means you're involved with differentiation. Okay, you're involved with differentiation. So over here, we will expect students to know differentiation. Okay, then show that P satisfies this equation. Okay, so we have to, that means in other words, this one is actually referring to step 1, form the equation. Okay, step 1 from the iteration procedure. So let's see how it works. So y equals to x squared cos of x over 2. That will be our original equation. I need to get dy dx. So I'm going to apply product rule. So dy dx here. Okay, differentiate u, keep the v, plus keep the u, differentiate the v. 1 over 2 sine x over 2. Okay, so I have a 2x cos of x over 2 minus x squared over 2 sine of x squared over 2. Okay, since they want stationary point, when we know that this one equals to 0. Okay, we know that this one is equals to 0. After that, I will need to do some sort of algebra rearrangement. So I have a 2x cos of x over 2 equals to x squared over 2 sine of x squared over 2. Okay, so simplify the expression. 2 bring up, become 4. X squared bring down, cancel with the x. Cos bring it over to the other side, become 1 over. Therefore, I have a 4 over x equals to tangent of x over 2. Okay, so according to the questions, it says that under these circumstances, okay, when this happens, x equals to p. Therefore, we know that tangent of p over 2 equals to 4 over p. That will be your equation. Okay, so as you can see, this question is asked about step 1. Okay, asking about step 1. So let's continue further. Verify by calculation, P lies in between 2 and 2.5. Okay, what actually happened in step 2 is Okay, in question II is they're asking for step 2. Okay, verify by using change of sign. So first of all, I need to let, okay, tangent of p over 2 minus 4 over p equals to 0 first. Okay, so let fx equals to tangent of p over 2 minus 4 over p. Okay, so sorry, tan f of p. Yeah. Okay, then after that I substitute f of 2 and f of 2.5 inside calculator. Don't forget this is a question involved trigo, therefore I need to change it into radian mode. So I key in, okay, tangent over 2 minus 4 over x. So calculate 2. I have a negative 0.443. Calculate 2.5. I have a 1.4096. So you will see that x is change of sign. Okay, x is change of sign. So the at least one solution in between, okay, to 2.5. Okay, so as you can see, so this I here is actually asking about step 2. Okay, and after that, step 3, use iterative formula Pn plus 1 equals to 2 arctangent of 4 over Pn. So they already give you step 3 here, which is algebra rearranging. Okay, the iteration formula to determine the value of P correct to 2 decimal place. Give the result of each iteration in 4 decimal place. So this part I here, they are talking about step 5. Okay, they're talking about step 5. There is one problem. I don't have my initial value. Okay, I don't have my initial value. So as you can see, they didn't give us my P naught. Okay, the first number P. Oh, sorry, again. This one is a P. Yeah. Okay. So therefore, I will need to identify my P naught by using information from step 2. You will see that negative 0.443 and 1.4096. Okay, so I will let my P naught, my initial value P naught here as 2 because as negative 0.443 is actually nearer to 0. Okay, this will be my step 4. Yeah. Okay, now I'm going to do my iteration procedure. Okay, for step 5. Okay, for presentation wise, you must show your first substitution. So P1 equals to 2 arctangent of 4 over P naught. Okay, so 2 arctangent of 4 over 2. Okay, so how do we actually key inside calculator? Okay, so from here I have my and the first initial value, okay, as 2. So I press 2 first, then I press equal. Okay, I press 2, I press equal. Okay, after that I'm going to key in 2 arctangent of 4 over answer. Okay, 2 arctangent 4 over answer, of course with a close bracket. I press my equal one time. Okay, that give me the first approximation, which is 2.2143. According to the question, it says 4 decimal place. Okay, then after that, I can write my P2. Okay, all you need to do is just press equal again. Okay, so you will see 2.1304. Okay, it's a 4 decimal place. P3 2.16 0.228, okay, for decimal place. P4, okay, 2.1502 for decimal place. P5, 2.1551 for decimal place. P6, 2.1532 for decimal place. Okay, it's like never change, never stopping. Okay, when should we stop? According to the question, it says find the value of p correct to do decimal place. You will see that the value is already stopped changing, isn't it? Okay, maybe we just write one more. So P7 equals to 2.1539 for decimal place. Okay, you will see that the number is stop changing here. So you can actually conclude that your alpha, the solution is 2.1542 decimal place. Done. Okay, and this is the chapter 6 numerical methods. Okay, over here there are exercises. Okay, mixed exercise 4C that you actually can do. Okay, this one, the answer is over here. You can actually go through the questions accordingly. Okay, that's all for today. Thank you very much. Stop recording.